Hi, this is Kate, and for my stats project, I was wondering how much caffeine Century seniors consume per day because I feel like teenagers in general consume a lot of caffeine, and I was curious if this is more or less or about the same at Century compared to other teenagers. So, my question is the amount of caffeine consumed by 17 to 18-year-olds or seniors at Century different from 17 to 18-year-olds nationwide? So, my null hypothesis is that the mean intake is the same as nationwide. I found this number 101.9 milligrams per day from the National Library of Medicine. They did a study on all 17 to 18-year-olds across the nation. And then my alternate hypothesis is that the mean intake is different than 101.9 milligrams. So my population of interest is seniors at Century High School, and the significance level that I'm going to be using is 0.05. Then the conditions for a one sample t-test are a random sample. So I numbered every senior in the class of 2025 Google Classroom 1 to 404. Then I used a random number generator to find 35 unique numbers from 1 to 404, and I emailed those students with my survey. And then I satisfied the 10% condition because I did a sample of 35 students, which is less than 10% of 404, the size of our class. And then since I took a sample of 35, which is considered large, the central limit theorem states that the distribution of X bar, the sample mean of caffeine intake, will be approximately normal. Then since I emailed the students the survey, some did not respond, which may result in non-response bias. I hypothesized that the students that did not respond may have not done so because they're embarrassed of a large caffeine intake, which would have made the sample mean that I got smaller than what would be expected or true. So here is me emailing the students. Here are the numbers that I got, the data. I put it into a spreadsheet. And then here's the distribution from the form. Okay, so for my calculations, I got a sample mean of 73.657 milligrams and a standard deviation of 70.124 milligrams. So then for the t-statistic here, I did my sample mean minus the parameter, and then divided by the standard error, which was the sample standard deviation, divided by the square root of the sample size, and I got a t-statistic of negative 2.383. Then I did the t-test in my calculator, and I got a p-value of 0.0229, which you can see here. And since my alternate hypothesis is not equal to, you can see we have the p-value on both sides. Then a 95% confidence interval for mu is 73.657, my sample mean, plus or minus 2.042, the critical value using DF of 30, since I had a sample size of 35, the degrees of freedom would be 30, and then multiplied by the standard error, which again is sample standard deviation divided by the square root of sample size. And then my confidence interval was 49.569 to 97.745. So since the p-value I got was 0.0229, and that is smaller than the significance level of 0.05, I will reject the null hypothesis. I got convincing evidence that the true mean caffeine intake for all seniors at Century is less than or different than the national mean intake for 17 to 18-year-olds of 101.9 milligrams per day. Also, another piece of evidence we have to reject the null hypothesis is that 101.9 was not even close to being in the 95% confidence interval, so we can conclude that it's not a plausible value. I think it would have made this project easier to study something dealing with food or an inanimate object rather than people. I had to deal with non-response bias when emailing the students because some people did not respond, and I think it would have been easier to do something with food. So that's maybe what I would change in the future. My results are generalizable to all seniors at Century since I took a random sample, but not all seniors nationwide since I only studied seniors at Century. And I cannot infer causation because the study was observational and students were not randomly assigned to a caffeine treatment. So that was my project. Thank you.